Energy is a fundamental human need. Our physical and economic well-being depends on having abundant energy. But the current way we power the world is putting our planet in jeopardy. We combust fossil fuels that release carbon emissions and air pollutants that harm our communities. But it doesn't have to be this way. We can have abundant energy and a sustainable environment without compromise. At Bloom Energy, we have a viable and scalable solution to this problem. Clean hydrogen offers the promise of solving our current energy crisis. Our modern lives require energy to be affordable, always on, and sustainable. The conventional way of creating energy produces carbon emissions, and creating energy with renewables doesn't provide always-on energy. Clean hydrogen meets the world's demands for a better form of energy. How so? Think of hydrogen as a way to bottle up renewable electricity for later use. Electricity is the ultimate perishable, but hydrogen can be stored for days or even months to create a reliable and secure source of continuous energy. The conventional way of making hydrogen is dirty and creates carbon emissions. However, clean hydrogen can be made through electrolysis, a process which uses zero-carbon electricity to split water into hydrogen and oxygen. This is done with a device called an electrolyzer. But right now, making clean hydrogen is too expensive. Nearly 80% of the cost of clean hydrogen comes from the electricity used to break the water. An electrolyzer that uses less electricity is a game changer for making low-cost, clean hydrogen a reality today. There are low-temperature and high-temperature electrolyzers. It's a fundamental law of science that breaking up water at high temperature requires less energy than at room temperature. The Bloom electrolyzer operates at high temperature and uses solid oxide technology. This enables our electrolyzer to create hydrogen with less energy. High-temperature electrolyzers require energy to stay hot continuously. But even accounting for this cost, our systems still consume less total energy than other electrolyzers. Here's how. A hydrogen-generating solar farm only produces power when the sun is shining. Theoretically, we could size electrolyzers to operate only when the solar farm generates power. But this would mean that the electrolyzers would sit idle most of the day. Such a design would significantly increase the cost of hydrogen production. A better solution is to incorporate battery storage as part of the hydrogen production plant. Both high and low temperature electrolyzers rely upon batteries to smooth the load and reduce idle time. Bloom's high temperature electrolyzers use a very small fraction of this battery stored energy to maintain temperature. Even after accounting for this, we use less energy than other electrolyzers. We are unveiling our electrolyzer after extensive laboratory testing. Results validate our efficiency expectations with electricity only and with heat integration. Unlike PEM and alkaline electrolyzers that rely on electricity to make hydrogen, the Bloom electrolyzer can substitute a good measure of electricity with heat. Bloom's energy efficiency is better over low-temperature electrolyzers when using electricity. But when we consider our electrolyzer's ability to integrate with both electricity and steam, our advantage improves and continues to grow. This advantage applies to scenarios where there is access to heat waste, excess heat, or heat that's cheaper than electricity. Steel, chemical, cement, and glass manufacturing account for 22% of global carbon emissions. At Bloom, we have a game-changing solution for these hard-to-decarbonize industries. The energy required to power high-temperature furnaces at these factories can be produced on-site using Bloom electrolyzers and renewable electricity. Excess heat from the furnaces can be fed into the electrolyzers as high-temperature steam, reducing the electricity needs of our system. Plus, there's no additional costs of transporting the hydrogen from a remote location. This system will result in the lowest cost hydrogen for these industries. We've collaborated with Baker Hughes to create integrated solutions to decarbonize industrial manufacturing. Baker Hughes can leverage its strong customer relationships, compressor technology, and thermal engineering expertise, while Bloom provides electrolyzer and hydrogen technologies. Nuclear power plants also produce thermal energy, which can be used by our electrolyzers. But that's not the only opportunity in this space. Nuclear power plants provide clean baseload power, but can't easily ramp power up and down, which means they generate a lot of excess power during the middle of the day. With the U.S. Department of Energy's Idaho National Laboratory, we're demonstrating how this excess electricity and steam can be leveraged by Bloom electrolyzers to produce low-cost, zero-carbon hydrogen. Future solar farms built for producing hydrogen at large scale will be located in places with lots of sunshine. Such farms can harvest the sun's energy as heat using concentrators or as electricity using solar panels. Harvesting heat energy from the sun is cheaper and uses less land than producing electricity with solar panels. The Bloom electrolyzer will use this solar heat energy and significantly lower the amount of renewable electricity needed to break water molecules and produce low-cost hydrogen. At Bloom, we've been working since 2001 to provide energy solutions that create positive global change. Our founders began innovating and developing solid oxide technology in the 1990s, building their first electrolyzers while working on NASA's Mars exploration program. They later reversed this technology to create and commercialize solid oxide fuel cells, installing and operating over 0.5 gigawatt to date. Our Bloom electrolyzer uses the same solid oxide platform and many of the same components, so our supply chain is secured. We have ramped up capacity and are ready to produce 0.5 gigawatt of hydrogen electrolyzers today, 1 gigawatt within a year, and over 2 gigawatts annually as market demands. When it comes to the energy crisis, there's no time to lose, and Bloom is ready now. We have the experience, supply chain, and manufacturing capacity to make low-cost, clean hydrogen a reality today. And our technology offers two huge advantages over low-temperature electrolyzers. 1, we can make hydrogen with less electricity. And 2, we can utilize lower-cost heat rather than more expensive electricity. Given that electricity accounts for nearly 80% of hydrogen production costs, the Bloom electrolyzer will be the cheapest way to produce renewable, clean hydrogen. The future is in sight, and we are ready to deliver abundant energy that's clean, reliable, and affordable to everyone in the world.